Okay, the application of Gauss law. Yesterday we discussed about the application of Gauss law when we take a linear charge density in a uniformly long wire. Second case, when the charge is placed at the plane of the sheet and we find out the electric field intensity for the plane sheet. Now today we have to find electric field intensity due to a uniformly charged thin spherical cell or that will be taken as hollow. So this spherical cell are to be taken with three parts. The first case is when r is greater than small r. Second case, this is the object is placed inside the cell. Second case, when r is equal to r, it means the electric field intensity found at the spherical cell. And the third case is when small r is greater than capital R. This is the third case when the object is outside the spherical cell. Now here we have to first consider r is greater than r. Now here we consider a charge q at the center. With the help of this charge q, we take a Gaussian surface, and this is the spherical cell. So this is capital R. What is this capital R? Capital R is the radius of a spherical cell. Now here we have to find the electric field intensity outside the cell. Now we are consider another Gaussian surface, and at the Gaussian surface we consider a small elementary area which is denoted by ds. So here at this point, which is outside the spherical cell, we find the electric field intensity. So at a point outside the cell, it means r is greater than capital R. This is a small r is the distance between the center and the observation point where we find the electric field intensity at point P. Now according to the Gauss law, closed integral E dot ds is equal to q by epsilon naught. We know the statement of Gauss theorem, that means the total electric flux in a uniform charge is placed in vacuum is equal to 1 upon epsilon times of the net charge enclosed in the sphere or in the surface. So that means closed integral E dot ds is equal to q by epsilon naught, where q is the charge inside the spherical cell. Now if this is a dot product, if you remove our dot product, we can use cos theta. So that means E ds cos theta. This theta is an angle between E electric field intensity and the area vector, that is ds. What is the angle? When E and ds both are in the same direction. So here we can say theta is equal to 0. Clear? Got it? That means electric field intensity and the area vector both are in the same direction. When both are in the same direction, we can say theta is equal to 0. And what is the value of cos 0? That is equal to 1. So with the help of trigonometry ratio, we remove cos theta with the number 1. If you are multiplying this number with 1, that is closed integral E ds is equal to q by epsilon naught. Now we know that electric field intensity at every point, suppose you have to take here, that means the electric field intensity is same. At this point, the electric field intensity is same. Why the electric field intensity are same? Because this radius is same for the whole sphere. So at every point, the electric field intensity is same. When the electric field intensity is constant, we can remove from the symbol of integration. That means E closed integral ds. What is this closed integral ds? This is the surface area of a sphere. So that means we all are know this closed integral ds is equal to 4 pi r square. So E into 4 pi square is equal to q by epsilon naught. Taking downward, E is equal to 1 upon 4 pi epsilon q upon r square, or this can be written as k constant, that is E is equal to kq upon R square. This is the electric field intensity outside the spherical. The second case, the second case is when here we find the electric field intensity at a surface of a cell. When we are consider at a surface of cell, we consider R is equal to R. Clear? Where capital R is the radius of a spherical cell and R is the distance for the point P where we find the electric field intensity. So we, according to Gauss theorem, closed integral as E ds is equal to Q by epsilon naught. We remove the dot sign, we can use E ds cos theta. Both are in the same direction. So we can say theta is equal to 0. When theta is equal to 0, that means the cos 0 is equal to 1. Therefore, E ds is equal to Q by epsilon naught. We all know the surface charge density is equal to charge upon area. Charge by area. Charge कितना है? How much charge is here? Q. And area is 4 pi r square. So Q is written as sigma multiply 4 pi r square. Put the value of Q in this equation. So that means closed integral E ds is equal to sigma by epsilon naught 4 pi r square. E is constant. Remove the symbol of integration. So that means this d closed integral ds is a sphere. So 4 pi r square. This 4 pi square is a cancel. That means E is equal to sigma by epsilon naught. This is the electric field intensity when the charge is placed at the surface of the spherical cell. The third case. The case third. Case third means first case when the charge is placed outside the cell. Second case when the charge is at the surface of the cell. Third is when the charge is inside the cell. Now here we take a charge Q inside the cell and here we find out the electric field intensity. This is a sphere and here we find the electric field intensity. It means small r is less than capital R. Capital R is the radius of the spherical cell. Small r is the charge. We find the electric field intensity at point P inside the spherical cell. Then according to Gauss theorem, E dot ds is equal to Q by epsilon naught. Remove a dot product E ds cos theta. We all know E and ds both are in the same direction. So that will be 0. Cos 0 is equal to 1. Closed integral E ds is equal to Q by epsilon naught. We all are know the charge inside the cell. That means there is no electric field intensity. So here that means E is equal to 0. It means there is no electric field intensity inside the surface of cell when Q is equal to 0. When Q is equal to 0, electric field intensity is also 0. It means that the charge reside in the cell, they have no electric field intensity. Got it? Any problem?